Remember that time when you needed to add one feature in your existing automation framework, and as soon as you start adding the code, your code starts to fail in different parts of your framework like domino effect. A simple change in the code turns out to be fixing different issues in different parts of your code, and you are left wondering why adding a new code has started failing everything. So if your framework is open for extensions but closed for modifications, you can easily add new features into your automation code without breaking existing code. That's where open close principles comes into picture, which can save hours and hours of your efforts. In this video I am going to show you how open close principle can help your automation framework transform into something which can adapt and scale effortlessly. Whether you are extending any new functionality or adding new code, following this principle can help you achieve this very easily and effortlessly. So let's dive into the open close principle and see how you can apply it to your automation framework. And trust me, this is going to save your countless time and effort of your future rework on the framework. So without any delay, let's get into the video. Let's move on to second principle, which is OCP. So now here OCP simply means open closed principle. So we will understand that again with similar steps. So first is definition. Let's understand what it says in terms of a definition. So software entities. Here software entities means classes, modules, or any functions, etc. Okay, should be open for extension but closed for modification. So once again I am repeating, each class or functions should be open for extension. That means it can be extended, right? If new functionality comes, it can be extended, but same class should not be modified. So that's what it says. Let's understand more on this. This means adding features to a code base without altering existing code. Okay, so like installing a new module without tearing down existing structures. So here this definition, if you see, it should be open for extension. That means we should be able to add new feature into the existing code, but existing code itself should not be modified. So that's where it means it should be closed for modification but open for extension. Okay, so let's understand more on this with a scenario. So here we are maintaining one scenario which says user management system needs to support different types of users, right? So now we have one user class, right? And now user can be of different types. For example, user can be a regular user, or any user can also be admin type of user, right? So who has some privileges of admins, right? So we are going to take this scenario. Now let's understand what is the problem before we apply this OCP, okay, open closed principle. Now we will see this, that user class is directly modified whenever a new user type is introduced. Okay, so since we'll understand this with the code also. So just understand what I'm trying to say here. We'll explain this with the code also. So user class is directly modified whenever a new user type is introduced, risking the stability of the existing system. That means if we have one class which is handling only regular user, now another requirement came, okay, we have another type of user who is admin user, who has some extra features or extra responsibility for admin users or extra privileges, right? So we need to add that user also in the current existing class or existing function, right? So how we can achieve this? We'll see this with a class. So over here, if you see, this was the class, right? User class. Private, these are some of the fields, name, email, role, or something. Now we need to include assign role method, which is going to assign the specific role to the user, right? So now here, if you see, access control is the method which is going to give the access as per the user requirement, right? So if we have role as admin, then it is going to behave like admin, like it is going to have some specific logic as per the admin. Maybe, some part of the application is going to be accessible to admin only, and If role is equal to the regular user or user, then it should not have some specific privileges, right? So this is how we are going to modify when we don't have OCP, right? Open close principle is not applied over here. Because of this, we have user class. Now we came up with a new requirement of assigning a new user type, which is admin user. So how are we going to do that? We had modified the existing class itself. We had modified over here user class, and because of that we have introduced one method assign role and access control. So through this we are going to control different logic as per admin and as per the regular user. So this is what we did here. Now let's come back to the solution. So how are we going to handle this? Because we had one class which was modified because we had one new requirement. And what our OCP says, it says that adding feature to the code base without altering existing code, which means we should never have modified this class. So we should have the option to extend this class such that we can implement new feature, but we should not modify this code. Okay, modification should only happen because it is required to modify the logic of that particular class. So whatever responsibilities related to that particular class is required, only those places we are going to change the logic. Otherwise we are not. So now how are we going to maintain this? Like, how are we going to handle this problem? So for that we have solution to use interfaces or inheritance, okay, to allow extending the functionality without modifying the user class. Okay, so through this we can implement open close principle in our current code. So what it says, so this is how we can implement. There are two ways. It says either we can, or both also, you can use inheritance or interfaces or both also to allow extending the functionality without modifying the code. So over here if you see, now instead of implementing in such a way that only one class is handling that request, and because we came up with new feature to add on, we had to modify the existing code which was not required in case of OCP. So over here if you see user, we had created one abstract class, and this abstract class is going to have name, email and access control. So because different type of users, today admin user came up, tomorrow any other contract user may come up. So we definitely should have the extension possibility, but if modification is required, that should only happen because we wanted to change some functionality related to the admin user, not because we are going to add some more users type, and because of that we are changing the existing code. So over here if you see, this is our abstract user class in which we have name, email and access control. These are the methods, and since this is abstract method, so whichever class is going to extend this class, this user class, has to give the implementation of access control. So now public class admin user is extending this user class. That means it has to provide the implementation to access control. Now whatever admin related logic is there, or business rules are there, or whatever features or privileges related to admin is there, this class can definitely handle that, right? Similarly, regular user also can extend, and whatever privileges or permissions are allowed to a regular user, that is also going to be get handled in this access control. Now tomorrow if contract user comes up and contract user related functionality also we need to add in the user class, we can simply create another class contract user, and that is going to extend the user, and whatever is the new functionality related to access control, that definitely can be handled over there, right? So this way what we are doing, we have closed the existing functionality for modification, but we kept open the existing structure to add more and more features. So easily here if you see, we can add more and more features. Existing code is not going to get hampered or get changed because of we are adding new feature, right? So this way we can handle this OCP. Now, what are the benefits? More or less, you will see the similar kind of benefits in all of 5 different principles. It also reduces the bugs because we are not changing the stable code, and this is also going to have stable, flexible system, and it can also be scalable because if tomorrow 10 different types of users comes up, we need not to change the existing functionality because we are adding the new feature, right? So because of this, we have flexible and scalable systems we are building, and because of this principle, we are not changing the existing functionality, but we are open to add new functionality. So that's related to the OCP. So till this point, it seems very easy and understandable because we understood SRP, which is single responsibility principle, and we understood OCP, which is open close principle. And more or less, if you see, the both principles are around changing the existing code. So till this point, it seems very easy to understand because SRP, single responsibility principle, or OCP, which is open close principle, both revolves around discouraging existing code changes and creating the new thing, right? And through that we can maintain the scalable and flexible systems to scale. And till this point, people understand, and after this they give up because they think that LID part will be more or less difficult to understand. But believe me, this is going to be easiest one to understand, and through this you will understand what is Liskov substitution principle, because it seems very, very tough to understand, but it is not. If you give some more attention to this, what I'm trying to say over here, it will be easier for you and you need not to look upon multiple videos. So this is going to be very easy for you. Now that you learned how open close principle can help you extend your automation framework without breaking existing code, you are good to go to build more flexible and scalable automation framework. But here's next challenge. What if your components of the framework behave differently than you expected them to be? So in the next video, we are going to see what is Liskov substitution principle, which ensures that the components of your framework can be substituted without breaking existing code. And this principle is very, very crucial to build maintainable and reliable test automation framework. So make sure to subscribe the channel because there will be new upcoming videos, which is very, very important for this whole automation framework design thing. So if you haven't subscribed, please make sure to subscribe. And if you found this video helpful, please like the video. And if you have any further comment, please drop any comment into the comment box. Thank you. See you in the next one.